All right, everybody, ready for a big finish today? We're going to do activity 4, even though it says activity 3 over here. Activity 4. So we're doing the same thing again, except we're going to fill in a missing piece. This is not as hard as it may appear. But before I begin, I got spectators that I'm going to get rid of. That's a K. Don't forget it's a K plus. Where was the minus? It was on the nitrogen. Couldn't be anywhere else. Over here, there's an Na. Where's the minus? It's on the O. Couldn't be anywhere else. Here's lithium. That was plus. Where's the minus? It's on the O. Couldn't be anywhere else. Here's the secret. Find the pair that's already there. So don't try to find this guy's partner. Clearly not over here. It's going to be in the box. This guy has a partner right there. They're different by only H plus. That makes them conjugate acid base pair. Which of those two has the extra proton? The one on the right. Its pKa is that of a neutral nitrogen. Do not tell me it's 10. That's an ammonium ion. Yes, ammonium ion is more general than you learned in 141, where it was just the one ion. Any nitrogen with a plus charge is called an ammonium. If one of the atoms attached is an H, its pKa is 10. That's not here. This is it's an amine, which doesn't like being an acid at all. Amines prefer being bases, but you're forcing it to be an acid here. And it's 40. You got to learn it. What's the pKb of the amide? pKb of the conjugate base of an amine is 14 minus 40. Negative 2,6. Very strong base. Okay. Now that means this is an acid-base pair. And it's got lots of H's that are possible pKa's. I didn't point this out before, and I could have. Your molecules in our other examples had multiple possible pKa's too. This one, I'll show all the pKa's you're supposed to know and tell you which one is the only one that's relevant. All right, so we have H's here and here, like there. And that's pretty much H on an sp3 carbon. We call that an alkane. pKa 50. I don't think you're going to take a 50 before anything lower than that. What about this H? That's on an alkene. Hey, that's in your notes already from today. 45. I don't think you're going to take an alkene before you take an alkyne. pKa 25. Do you remember what I said about strong acids and weak acids? Let's use that information. Strong acids have negative pKa's. Well, none of these is strong. But of these three, one is by far the strongest. The lower the number, the stronger the acid. Makes sense. If a strong acid has a negative pKa, well, then if you're positive, then the closer you are to 0, the better it is. So the only number that means anything here is this one. It's the first one that's going to react. It's 10 to the power of 20 times more reactive than that. And it's 10 to the power of 25 times more reactive than that. I don't care about these two numbers anymore. They're gone. I don't care. So the lower number means that's the H you got to take off. So you're going to put a C minus right there and copy the rest of the molecule. Okay, so we got a carbonyl. Comes up to an O. CH2, CH2, C double C. Don't touch the C double C. Comes down. Yeah. C triple C. And an anion right there. There's an anion at the end of the C triple bond to C. Okay. And that has a pKb. What was the pKa of the acid you just took off? 25. Okay, we're doing okay. All right. So which arrow are we supposed to circle? The one that points to the bigger pKa or the lower pKa? The bigger pKa. Finally, we got an arrow that points to the right.
Wait,
Lower pKa means more reactive. Equilibrium always goes away from the more reactive acid towards the less reactive acid. I think we still have a question though. Nope. Okay. So 25 of these three is the one that reacts first. We don't have numbers for anything else there. If you're thinking this is a carboxylic acid, please rethink. There's no H on the O. It's not a carboxylic acid. It's an ester. What else do we need to know there? Not much. No. Oh, I noticed over here I didn't finish crossing off spectators. This one has 2 spectators, which means that's the carbonate ion over there. So that's the pair that's already there. Which one of those is the acid? Well, the one on the right doesn't even have a proton. Please don't try to call it an acid. The one on the left has the extra proton. It's the acid because of that. And that is bicarbonate. You got to learn that's one with a pKa of 11. Bicarbonate, it's on your table. That means carbonate, its conjugate base, has a pKb 14 minus 11 equals 3. That means these are a conjugate pair. And we got to ask the question. If this is a base, that means it's reacting with an acid, right? An acid. This can't be a base. Each side of the equilibrium has an acid and a base. If that's not true, you did it wrong. So this acid will react with this base. This base is the conjugate base of this acid. Which H is coming off first to make its conjugate base over here? Is it the 10 for the ammonium ion? Or is it the 17 for the alcohol? It's not even close. The ammonium ion is 10 million times more reactive. Show me you know that. And that means take its H plus off. And yes, once you've crossed the spectator off, you don't even have to acknowledge that it was ever there. Okay, and the pKb of this, 14 minus the pKa that you just used, pKeq. I don't think I did pKeq for the top one. Ooh, let's do those in black. pKeq top, pKeq bottom. Left pKa was 25. Right pKa was 40. Negative 15. Here the left pKa was 11. The right pKa was 10. And up here, KEQ equals 10 to the positive 15. Here, KEQ equals 10 to the negative 1. And that means we should circle the arrow pointing to the left again. Because 11 is higher than 10. I want to remind you, we didn't use the 17. Please don't. In fact, if you're like me and you don't cross it off, you might be tempted to use it. Cross off those ones that were not relevant. Okay. So there you have it in a nutshell. You have a whole page of these on your next test. And I think that was a good start for chapter 4. We're going to get into buffers and things, but I want to tell you something you didn't know yet. There's no class on Monday. It's canceled. It has nothing to do with Henry Ford. It has to do with my grandson. I'm going to be down south. So no class Monday. I will send an email reminder before I leave for Georgia, which is in about an hour. And I wish you all a great weekend. Do you have any last minute questions? I'm going to make this. Sorry, go ahead.
Oh, I think you were just about to answer it. This we're going to turn in as well, right?
Yeah, I'm going to have a setup area very soon, and I'll make it due at 1. Okay, but you'll have a grace period till 1:05. So yeah, there's no stress on this one, I don't think. Okay.
Dr. Whitaker,
Yes.
do you have a PDF file for the chapters that are for the next test?
I don't have that yet. I'll have to get back to you on that. I haven't heard from my guy yet either. I forgot all about it. Okay, I'll get back to you.
Okay, thank you.
All right. And so far so good. And
Question, please.
oh, we have another one.
Oh yeah, I'm sorry. So you were talking about a table that has the values of the pKa's and
Yes.
where is that found?
Chapter 4. It's the biggest table in the chapter. Start skimming from the beginning. It is not very far in. I don't want to go with a page number because then students will start saying, oh, what page number? Oh, we didn't. I don't remember. Oh, I won't even look. No, it's there. I promise. It's huge. It says pKa's you must know. And it's only pKa's, the whole page. Okay. Strong acids on the bottom, weak acids on the top. Okay. It's there. I promise. Chapter 4. All right, everybody.